Good morning students, welcome to the MOOCs online class, and we already dealt with some of the conceptual understanding of operations research in part 1 and part 2. Let us move to part 3. And yes, queuing model. A queuing system comprises both the customer and server, and the customers have arrival rate and server has service rate. This arrival rate is represented with lambda or del, and the service rate is represented with mu, and the utilization factor phi is denoted by del by mu, and it should always be less than 1, as the arrival rate greater than the service rate, then the customers will be left over after 1 hour. Let us take this rate per hour. Then a source may be finite or infinite. It will be finite in case of machine maintenance, as they may be allotted to maintenance crew, and infinite in case of mailing systems. Then service discipline, it represents the order in which customers are selected from a queue. FCFS, LCFS, SIRO, first come first serve, last come first serve, and service in random order, and may also be based on priority. Then bulk arrivals, customers arrive in groups and jockeying, customers attempt to jump to a smaller size queue, and renizing, customers already in the queue leaves anticipating long delay. And the next one is bulking, if the queue length is large, customers won't join. Then moving to the Kendall notation, P, Q, R, X, Y, Z. Here P is the arrival rate, Q service rate, R is number of servers, and X is the service discipline, Y is the number of customers permitted in the system, and Z is the number of calling sources. There are 3 types of models: MM1, GD infinite infinite, MM1 GD n infinite, and MM1 GD n n. In the case of the first model, we have a single server and infinite number of customers permitted in the system and infinite number of calling sources. We can calculate LS, LQ, WS and WQ, where LS represents the average number of customers waiting in a system, whereas LQ is denoted for queue, and WS and WQ are for waiting. Then the second model is MM1 GD n infinite. Here n number of customers are permitted in the system, and hence the del value is not the actual del. We should calculate the effective del, and hence we have to find out P n values and the probabilities. Then MM1 GD n n, here the number of calling sources and number of customers permitted in the system both are finite, and hence here also we have del effective, and we can also find out LS LQ and WS WQ. We can also find out the utilization factor phi is equal to del by mu. Then moving to the queuing cost models. Queuing cost models have 2 types of costs: cost of operating the service and cost of delay in offering the service. Expected total cost ETC is equal to expected cost of operating plus expected cost of waiting. Here the operating cost EOC is equal to marginal cost per unit of X multiplied with X units. Then expected waiting cost is average number of customers waiting in the system multiplied with the cost of waiting per unit time. Then moving to the network models. A network is a graphical representation of a project, and it should never be a loop. It should have one starting point and one ending point, and it has activities, events and dual events. Here activity, it is a task or work, and it consumes time and resources. Event, it is represented by nodes. Between 2 events there is an activity, and a dummy activity is introduced and the number of working days should be 0. Dual event, it should be at least having one predecessor and a successor, or at least one merge and burst event. So, for a network of n events, we should have n minus 2 dual events, as the starting event won't be having a predecessor and the finishing event won't be having a successor. Then moving to the critical path, it is the longest part of the network. Then moving to the next concept, scheduling a project. Scheduling tells you when each activity should be done, what has already been completed, and the sequence in which the things need to be finished. The schedule essentially transforms the project from a vision to a time based plan. Schedule helps to do monitoring, controlling the project activities, determining how best to allocate resources, so you can achieve the project goal, assess how time delays will impact the project, and figure out where excess resources are available to allocate to other projects, and provide a basis to help you track the project progress. Then moving to the scheduling tools, there are 3 types essentially, and the first one is schedule network analysis. This is a graphic representation of the project's activities, the time it takes to complete them, and the sequence in which they must have to be done. We use PET charts, program, evaluation and review technique charts. And then the critical path method, this is the process of looking at all of the activities that must be completed and calculating the best line or critical path to take, so that you will complete the project in the minimum amount of time, and the method calculates the earliest and latest possible start and finish times for a project activities, and it estimates the dependencies among them to create a schedule of critical activities and dates. Then moving to crashing, this is where you assign more resources to an activity and thus reducing the time. Then compare between PET and CPM. Here PET, it is a probabilistic model with uncertainty in duration of the activity, whereas CPM is a deterministic model with well known activity duration. PET is event oriented, whereas CPM is activity oriented. PET is suitable in defense projects, research and development. CPM is suitable for plant maintenance and civil construction projects. PET uses slack for rescheduling, whereas CPM uses float for rescheduling. Then moving to crashing a project. Project crashing is when you shorten the duration of a project by reducing the time of one or more tasks. The reasons for crashing are market pressures, unforeseen delays, incentives for early completion, imposed deadlines, pressures to move resources elsewhere. Generally, the normal time is greater than crash time and the crash cost is greater than normal cost. These are the resources. For more information, the concepts and resources are available. There are some textbooks and video links available. Please go through them in case of any doubts and queries. Thanking you.